with photons, atoms, big molecules. When the guy, Antoine Zeilinger, who did the thing with big molecules, two places at once, was asked, what's the limit? How big a thing can you do it with? What limits you? And his answer was, only budget. And hey, today, well, this is a decade or so ago, the experiment was done with what they call paddles, these little things which are looked at with an electron microscope. And these paddles vibrated, so each paddle was in two places at once. Simple harmonic oscillator motion for physicists. And each paddle was big, well, big. Each paddle contained 2 times 10 to the 9, 2 billion atoms in two places. Look, we're not talking about a single little particle. Well, it's pretty little. But if you Google, this is just something that came out last week. If you Google Schrodinger's drum, D-R-U-M, on the, you'll find that a square millimeter membrane, they're talking about a square millimeter membrane, which I calculate contains 10 to the 16 atoms, that's 10 billion atoms, can be in two places at once, and they're doing that experiment right now. Okay, so here's another more recently, like 1970s, a demonstrated quantum enigma that also involves free will. It also involves free will. You know, what someone freely chooses, important, what someone freely chooses to do in, say, Paris or on Mars, can instantaneously, fast to the speed of light, instantaneously, though randomly, influence what happens to you in Santa Cruz without any physical force being involved. This is mysterious, right? It's an EPR Bell, so-called EPR Bell interaction. And hey, but you know, there's two quantum enigmas. One involves reality and one involves connectedness. This is connectedness. The first one was reality, what was really there before you looked. And but we can avoid both enigmas. We can avoid both enigmas by denying free will. To say we don't have free will. We're, I don't know what you want to call us, automatons, the philosophers sometimes call it, call them zombies. What I apparently, however, but we must, if we deny free will, it turns out we must then assume a completely deterministic and conspiratorial world. What I apparently choose to demonstrate in the boxes, for example, it was actually the case. It was actually true. In box pair set A, the objects were things in both, separated into both boxes. With box pair set B, the things were concentrated in one box, and I had to choose to those experiments because the universe conspired not only to deny me free will, but to make everything coordinate so I think I have free will. Okay? Nature correlates my choices. Actually, John Bell, who's probably the leading quantum theorist of the latter half of the 20th century, we dedicate our book to him. I've had many conversations with him. Actually, the year before he died, I was chairman of this department, and I invited him. I actually had a budget, which was unusual, and I actually invited him to come and spend some time in Santa Cruz. And he sort of said he'd agree next time he's in the U.S. But he died less than a year later, fairly young. He would have won a Nobel Prize if he had not died, almost for sure. But let's see, here's something he said about this conspiracy. He said that if we want to deny free will, we have to say that, hey, apparently separate parts of the world would be deeply and conspiratorially entangled, and our apparent free will would be entangled with them. But this way of arranging, I'm continuing with John Bell, but this way of arranging quantum mechanical correlations would be even more mind-boggling than one in which chains go faster, causal chains go faster than light. Hey, I don't know that there's free will. No, I don't know. I might be a zombie. Even me? No. Okay. You maybe. But hey, I find that even more mind-boggling. But realize that the quantum enigma only comes about because I think I have free choice. Hey, there's a. You don't like the conspiratorial universe? I don't think most people do. Hey, there's another way out. Another way out. Hey, just accept quantum theory all the way. Just assume that we observers are part of the world explained by quantum theory. We're just part of the universal wave function, to use a word. We make no free choices. We simultaneously make all choices. We do all possible experiments. We simultaneously are conscious of all possible results of those experiments. It's called the many worlds interpretation of quantum mechanics. It's 50 years old. But since the interest in these quantum mysteries has been increasing so much today, that Nature is one of the most respected science journals in the world. The original DNA stuff was published in it. Lots of other important things are published in it. The Nature cover in July 2007 honored the cover story, honored the many worlds interpretation because it's getting so much attention. But they realize it's kind of weird. And here's the cover. It doesn't look like a prestigious British journal. It looks more like something on a supermarket checkout counter. 50 years, but their only news peg for putting it on, nothing new was found in July 2007. The only news peg is, hey, this interpretation is getting renewed interest today. Ultimate quantum strangeness in whatever. It's okay. So you have 4 logical options of dealing with the undisputed facts. Hey, people are on all sides. Pick your option. You have, to the extent you have free will, you can pick your own option. Sometimes when we write exams, you can't pick your own answer because my free will comes in. Okay, physics has encountered consciousness with this quantum enigma and free will. Hey, they are tightly entwined. The two, of course, are. It's a mystery. We should admit it and tell it widely. Tell people about it. Profoundly changes your worldview. Option 2, we have, as Jauch said, a skeleton in our closet. And he didn't say, he said this, he didn't say, it's something we should not talk about. He actually talked about it. Option 3, we have a totally deterministic universe that mysteriously conspires to make us think we are independent observers of it. 4, many worlds. Quantum theory's explanation is complete. We're just part of the quantum system, and everything happens all the time.